Now we are going to discuss about an important and interesting property called induction. The title of this lesson is electromagnetic induction. In this induction is very important. Before this concept, we have discussed about the reasons of the inductions and different experiments did to prove the induction property, maybe due to the self-induction or mutual induction. So what is the meaning of induction? Suppose a magnetic flux changes, it produces an induced EMF in the coil. This production of induced EMF due to the change in magnetic flux is called electromagnetic induction. The current which is produced due to this experiment or phenomenon is called induced current or induced EMF. Induced EMF or induced current. Induced current we can represent as I. Induced EMF we can represent as E. So what we can write? Induced EMF is equal to d phi b by dt. And this d phi b by dt is equal to, we can write di by dt. Derivations and derivation part will be cancelled out and we can write phi b is equal to I, or phi b is proportional to I. We can write like this because EMF is also proportional to rate of change in flux. This is for one turn, but for n turns, capital N turns, we can write n phi b is proportional to I. If you remove the proportionality constant, we can write it as Li, where this L is called inductance. Its SI unit is Henry. Symbol is capital H. Its dimensional formula is M L square T power minus 2 into A power minus 2. So what is the meaning of inductance? Production of current or electric current or induced current due to the change in magnetic flux within a coil is called inductance. This inductance is classified into two types. First one is mutual inductance. Second one is self-inductance. What is the meaning of mutual inductance? It is, if you go back to the experiments did to prove the induction property, if change in flux occurred in one coil, it causes to produce an induced EMF in the nearest coil, maybe of the different turns or equal number of turns. That is said to be mutual inductance. What is said to be self-inductance? Change in magnetic flux due to the magnet's position in front of the coil, and it creates a change in EMF within the coil. There we used one magnet, one coil. Here we used, in mutual inductance, we used two coils of n number of turns or unequal number of turns. In one conductor or one coil, it produces the induced magnetic field, and another one can create an induced EMF. Now we are going to discuss the equation parts of these two induction properties. Now we are going to observe the mutual induction. Mutual induction means it is like a mutual understanding between the same category materials. So what is this mutual induction? So it is very difficult to draw as it is in the textbook, but if you try to see S2, S1, I, O. S1, S2, I, O. What is the meaning of these four letters? What is this S1? This S1 and I both are same. What is this I? Inner coil. In terms of magnetism, these coils are said to be solenoid. That's why we can say it as a inner solenoid. Same like O is equal to outer coil. So O and S2 are similar. Therefore, S2 is called outer solenoid. So now what we can observe, this inner solenoid, see the width of the or size of the solenoid coils, number of turns like this. It has some radius R1, but the outer solenoid radius R2. These two are wounded on a rotating axis like this. Now, if magnetic flux changes in the inner coil, it can produce the induced EMF in the outer coil. Means magnetic flux changes in the S1 produces an induced EMF in S2. If magnetic flux changes in S2, it produces an induced EMF in the S1. That means induction property between these two coils are vice versa to each other. We know that. So, if flux through S1 is phi1, which has n number of turns, or n1 number of turns, which has n1 number of turns. Therefore, flux is equal to directly proportional to I. We know that. So, such like that, total flux or total change in flux through S1 is given by N1 phi1 is equal to M12 I2. Change in the coil 1, flux change in the coil 1 produces the current in coil 2. That is very, very important. What is this M12? Mutual inductance of S1 due to S2. So we can write N1 phi1 is equal to, what is this N? Total number of turns. So it has N1 number of turns. Each turn has length L. Therefore we can write N1 is equal to small n1 L. Therefore N1 is equal to number of turns, L is equal to, small l is equal to length of each turn. So we can do like this. Then what we can understand with this expression is N1 phi1 is equal to N1 L. What is flux? B dot A, BA, where B is equal to mu naught Ni, A is equal to area of the inner coil because it is phi1. So therefore phi1 is a change in flux. So BA cos theta is the flux formula. Therefore we can write pi r1 square mu naught n2 I2. This refers to B, this refers to area. Phi1 is equal to BA. Now we can equate this equation like this. Already N1 phi1 is equal to, we can write M12 I2. Let us say this is some equation 1. Now we are going to see the comparison. So N1 N2 mu naught pi r1 square L I2. If you wrote this equation in an order, we will get mu naught n1 n2 pi r1 square L I2. This is equal to n151. But we know that n151 is equal to m12 I2. So from equation 1, m12 I2 is equal to mu naught n1 n2 pi r1 square L I2. If I2 I2 get cancelled, we can write mutual inductance of coil 1 due to coil 2 with respect to coil 2 is called mu naught n1 n2 pi r1 square L. This is the expression for mutual inductance of one coil with respect to the another coil. This is with respect to S2. Now we will see the vice versa case. Now the vice versa case is like this. N2 phi 2 is equal to M21 I1. So what is this M21? Mutual inductance of coil S2 with respect to S1. To coil S1. Now we are going to write the equations for this N2 phi 2 and equating the M21 I1. Let us say this is some equation 3. We already got the equation for N12 before. So what is this N2? We can write it as N2L because N2 turns, each turn has length L. The multiplication product is said to be N2, means total number of turns in the secondary coil. Okay, so the total number of coils is equal to each turn into number of length of the each turn. So now we can write N2 phi 2 is equal to N2L into this phi 2 is nothing but B dot A. So pi R2 square into mu naught N1 I1. This refers to B, this refers to A. So phi is equal to BA. So again we can write N2 phi 2 is equal to mu naught N1 N2 L pi R2 square I1. We got the equation like this. So it is not divided by A or divided by B. We can write A is equal to pi R2 square and B is equal to mu naught N1 I1. So now N2 phi 2 is equal to M21 I1. Therefore M21 I1 is equal to mu naught N1 N2 L pi R2 square I1. I1 and I2 get I1 get cancelled on each side. So therefore we can write M21 is equal to mu naught N1 N2 L by R2 square. If you see the equations of the previous one and this one, these two equations are having same value. But what is the physical significance of these values? We are going to see now. Next we will see the useful expression for the mutual inductance. What we can understand, M12 is equal to M21. Suppose we can write M12 is equal to M21 is equal to M, then the equation will change like this. Mu R relative permeability, mu naught N1 N2 pi R1 square L. So what we can understand, N phi is equal to Mi or N1 phi 1 is equal to M1 to I2. We know that. Now I am applying the differentiation on both sides. D by dt of n phi 1 is equal to d by dt of mi2, let us suppose. We know that d by dt of n phi 1 is equal to minus EMF. Therefore, EMF is equal to minus d by dt of n phi 1. So therefore, we can write EMF is equal to minus of d by dt of mi2. So therefore, minus m into di2 by dt. This is one more expression for the EMF with respect to the inductance and current. So we can write E in proportional to inductance and di with respect to dt. So this is the expression for mutual inductance of coils C1 and C2 with respect to their radii R1 and R2 with respect to their mutual inductance M12 and M21 and current passing through them. Now we will see one problem. Two concentric circular coils means two circular coils which has same center. One of small radius R1 and the another of large radius R2, such that R1 is much less than R2, means we can neglect the radius R1 when compared to the R2, are placed coaxially with the centers coinciding. So obtain the mutual inductance of the arrangement. So what we can understand from this problem, one is R1 radius, another one is some R2 radius, but we can say R1 is much less than R2. If this is the case, what is the way to find out the mutual inductance? So now two coils, mutual inductance means maybe M12 or M21. So we can write like this. What is the flux? We know that BA. Phi 1 is equal to B1 A1. What is B1? Mu naught I2 by 2 R2. What is A1? Pi R1 square. Now try to simplify this equation or adjust the equation like this. Mu naught pi 2R2 into pi R1 square into I2. This is the flux equation. So phi 1 is equal to what we can write for n number of turns? M12 I2. So from this comparison we can write M12 is equal to mu naught pi R1 square by 2 R2. So according to the symmetry we can write that M12 is equal to M21. Therefore M12 is equal to M21 is equal to mutual inductance So therefore mutual inductance M is equal to mu naught pi R1 square by 2R2. So this is the final expression of this type of problem. And in the same type of problem, they will give the radius R1 with respect to one particular value, R2 one particular value, and they will give the remaining values also. They will ask to find out what is the mutual inductance of the system. Then we should remember this formula to simplify the equation in simplifier. So these type of formulas are very, very important and works as a shortcut in competitive exams. Self-inductance. So what is the self-inductance? The previous example, we saw that change in flux in one coil and induced EMF in the nearest coil. But in self-inductance, change in flux due to the magnetic field which is outside, or change in flux inside the coil, with respect to that, in the same coil only we can see the change in EMF or induced EMF. So this is called self-inductance, means flux is directly proportional to current. For n number of turns, we can write the same expression. N phi b is proportional to I. If you remove the proportionality constant, N phi b is equal to Li. This L is called self-inductance. This L is called self-inductance, but we know that EMF is equal to d phi b by dt. If N phi b is equal to Li, we can write L is equal to N phi b by I. EMF is equal to d phi b by dt. Therefore, EMF is equal to minus d phi b by dt minus d by dt of Li. Therefore, it is minus L into di by dt. This is the expression of EMF with respect to self-inductance and current. And in the previous example, we have seen the expression for the EMF with respect to mutual inductance and rate of change in current. Here it is self-inductance into rate of change in current. So, how we can write N phi b? We can write N phi b is equal to N is equal to small n into L, N number of turns, and L is the length of each turn. Phi b is flux. Flux is nothing but B into A, where B is equal to mu naught Ni, A is equal to A. So finally this expression will be mu naught N square A I L is equal to N phi b. So we can write N phi b is equal to mu naught N square A I L. We know that N phi b is equal to Li. Now I am writing the same equation to compare these two. Therefore, Li is equal to mu naught N square A L I get cancelled, therefore L is equal to mu naught N square AL. For the relativity case or relative permeability case, it will be written as mu r mu naught N square AL. So, what we can understand with this expression? If self-inductance is playing a key role within the coil, this self-inductance creates a back EMF. Means, if you see the Faraday's experiment, the EMF is always opposing the change in flux. That EMF is called back EMF, and the self-inductance acts as a back EMF, produces the back EMF and acts as a resistance. Self-inductance produces back EMF, comma, and acts as resistance. So the amount of work done by this flux to overcome this resistance and to overcome the back EMF stored in a form of magnetic potential energy. So work done, power is equal to dW by dt. Therefore, dW by dt is equal to EI. So power is equal to IV. In place of V, we are writing E. Therefore, so we can write dW by dt is equal to, in place of E, we can write Li. So L into di by dt into I. E is equal to L into di by dt. Therefore, if you write the expression in a correct order, dw by dt is equal to L I di by dt. So on integrating each side, so therefore integral dw by dt is equal to integral Li di by dt. Dt get cancel out. Therefore integral dw is equal to work done half Li square. It is analogous to work done is equal to half m v square. So what is this analogy? How it is comparable? We are going to discuss now. So what is the comparison? W is equal to half Li square and W is equal to half m v square. L and m are comparable to each other. What is m? Actually it is mass in mechanics. Mass increases, it causes to inertia. It causes a property called inertia. So m is similar to inertia also. That means we can write L as electrical inertia. Which opposes the rate of change in current in the coil. That's why it is electrical inertia. In other terms, we are calling it as induction. So, what is the expression for L? M11 I1 plus M22 I2. So, in case of EMF, it is minus M11 into dI1 by dt minus M22 into dI2 by dt. Therefore, we can write M11 is self-inductance. We can write M22 is self-inductance of the second coil and M11 is the self-inductance due to the first coil. Therefore, E is equal to minus L1 dI1 by dt minus L2 dI2 by dt. This is the expression for the complete analogy of the inductance and rate of current to the EMF. Obtain the expression for the magnetic energy stored in a solenoid in terms of magnetic field B, area A and length L of solenoid. How does this magnetic energy compare with the electrostatic energy stored in a capacitor? This is one of the problem which is related to the self-inductance property. We should find out the magnetic energy stored in a solenoid, but that formula should in terms of magnetic field, area, length. So how we will get this? Magnetic energy expression is UB. This UB magnetic energy is equal to half Li square. This is not enough. We should convert this formula in terms of BAL. So UB is equal to half. What is L? Self-inductance. Self-inductance in terms of BAL, it will be written like this. Mu naught N square AL. What is I? B is equal to mu naught N by I. Mu naught I by N. So therefore, what is I? B by mu naught N whole square. So half mu naught N square AL into B square by mu naught square N square. So see the calculations. N square get cancelled, mu naught square cancel out. Therefore, we will get UB is equal to B square by 2 mu naught into AL. This is the expression for magnetic energy in terms of BAL. What is the second bit? How does this magnetic energy compare the electrostatic energy in a capacitor? So, what is magnetic energy per unit volume? UB by V. What is UB magnetic energy? B square by 2 mu naught into AL by V. What is this V? Volume. Volume we can write AL. So therefore, B square by 2 mu naught into AL by AL. AL get cancel out. Therefore, UB is equal to UB per unit volume is equal to B square by 2 mu. So the second part of the bit is how this is comparable or similar to the electrostatic energy. So we know that electrostatic energy per unit volume in a parallel plate capacitor is equal to half epsilon naught E square. If this is the case, if you go back to the magnetic energy per unit volume, we got half B square by 2. See, magnetic energy per unit volume is proportional to the square of the magnetic field, and electric energy per unit volume inside a capacitor is also directly proportional to the square of the electric field. So this is the comparison we can understand. Now we will see an important application of electromagnetic induction. Producing the AC current is the best example of the electromagnetic induction, best application of the electromagnetic induction. So as the coil rotates, alternatively changes the direction of magnetic flux, it produces an induced EMF. This is the principle behind it. Mr. Nikola Tesla is an Yugoslavian. He discovered this apparatus, and this apparatus now it is useful to produce some 100 megawatts, 1000 megawatts of AC current, which is in the thermal power stations. So what is the arrangement of this AC generator? It is able to produce AC current. This is the best application of electromagnetic induction. Now we will see one of the example or applications of electromagnetic induction, that is AC generator. AC generator which is able to produce some 100 megawatts of AC current through the electromagnetic induction process. This phenomenon and this experiment was did by Nikola Tesla. He was succeeded. That's why this is the apparatus which he has shown with respect to his experimental support. What are the contents in this AC generator machine? Two strong magnetic poles, north and south. In between these two magnetic poles, one armature coil is placed. C is coil. And this armature coil is connected to two carbon brushes. Okay, so this one split rings. These two rings are connected to the two carbon brushes, and the ends of these two split rings and carbon brushes are connected to the AC EMF source. How the AC current will produce with the help of this AC generator? Listen, north pole always attracts the south pole. That means field lines travels from north to south. So this is the axis of rotation. With respect to this axis of rotation, this coil rotates. See the direction of rotation. Means because of the repulsive force, this rotation takes place. And as the rotation takes place, the rotational angular constant which is connected to these two brushes converts this DC magnetic flux to AC magnetic field or AC EMF. So change in flux converts to AC EMF. Whenever this coil is rotating, it is experiencing the magnetic flux within an area. So magnetic field or field lines passes through one unit area of this conducting plate or armature coil is called magnetic flux. It is said to be phi B. So rate of change in flux is equal to EMF. We know that. Now what is flux expression? D by dt of BA cos theta. So flux is equal to B dot A, therefore phi B is equal to BA cos theta. So what we can write, theta is equal to omega t. So therefore EMF is equal to d by dt of BA cos omega t. Now it is the same application for n number of turns. It will be like this. EMF is equal to d by dt of phi b. We can write d by dt of BA cos omega t. For n turns, this EMF will behave like this. D by dt of, what is phi b? N A B cos omega t. For n number of turns, we are multiplying with n. So derivation of cos omega t is equal to omega sin omega t. Therefore, EMF is equal to minus N A B omega sin omega t. We can write this one as EM. Therefore, E is equal to EM sin omega t. So what we can understand with this expression? Induced EMF is a function of sine. So sinusoidally it is varies. What is the sine limit? 0 to 90 it is 0 to 1. 90 to 180 it is again 1 to 0. So in between 90 and 170 it is 1 to minus 1. That means as the values are changing from 0 to 180, values changes from 0 to 1 and 1 to 0. This is said to be sinusoidal variation. That means the EMF which is produced due to the alternative change in the direction of armature coil in the presence of magnetic field is a function of sine. So that is nothing but AC current, because only AC current has the variations from 0 to 180. For direct current, it is a straight parallel line. So how the graph will be, we are going to see now. This EM is a maximum EMF. Now we will see the plot between the induced EMF and time. Induced EMF. This is time. At t is equal to 0, it starts with 0. This is t by 4. T by 2. This is T. This is 3T by 2. Like this we can write, we can extend this one like this. This is 2t. Five t by 2. So this is the graph, means 0, t by 4, t by 2, 3t by 4, complete t, 0 to t. Next t to 2t, 2t to 4t, like that. So this is at pi, this is at 0, this is at pi by 2, this is at pi. Again it is 3 pi by 2, 2 pi. Next one, so 5 pi by 2. So like that it will be continued. So what we can understand is, see, 0 to 90 maximum amplitude, 180 again 0, 270 negative amplitude maximum, 360 again 0, 450 maximum amplitude, 540 0, 630 720. So like that, at theta is equal to 90 degrees, maximum amplitude, because sin 90 is equal to 1. At theta is equal to 270 degrees, minimum amplitude, because sin 270 degrees is equal to -1. In case of AC generator, the minimum amount of energy required to move the armature coil is provided by the magnetic fields. Suppose in case of commercial power generators, now we are using the thermal power stations and hydro power stations, there mechanical energy is to be supplied to rotate the armature coils. That mechanical energy may be a steam, maybe nuclear energy, whatever. If nuclear energy is used, that is set up in nuclear power stations. If thermal energy is used, that is set up in thermal power stations, like that. Mostly in India, AC currents frequency. In India, frequency of AC current is 50 Hz. But in USA, it is approximately equal to 60 Hz, more usage. So this is one of the way to understand the graph between the induced EMF to the time. So in this lesson, we have discussed about the induction, experiments did to understand the self-induction and mutual induction, eddy currents, applications of eddy currents, uses of the power generators, and one more thing, expression for the mutual induction and self-inductions, and uses of the working principle of the AC generator. So by this point, we can conclude this lesson.